Hi, today I'm going to do a really interesting experiment using the device I got from DF Robot. So let's open it up and see what is inside. Also, link to buy this product has been provided in the description. You can check it out from there. So anyways, this is a wireless energy transmission device with a transmitter and a receiver end. This what you see is a 12 volts bulb and I'm going to connect it to the receiver. And to power up the transmitter, here I'm going to use this 9 to 24 volts power supply. So now that everything is set, let's turn on the supply. It's full 24 volts, although the bulb is not lighting up. Let's bring them close and see. Oh, yeah, now it's working. Nice. Although here we can see this small LED lighting up. I'm going to give you a closer view on that. You see that small red LED? So it is glowing, indicating that it is receiving signals from the transmitter, but the signals are not strong enough to light up this big bulb. So guys, I've done this setup in which this is the transmitter and I've held it with this clip, and the receiver, the coil is held with the other clip. Now here I'm going to do the distance measurement at which this bulb is going to glow. Turning it on. And the bulb is not glowing right now, so I will have to bring them closer. Oh yeah, and it has started glowing a little bit, so I'm going to turn off the lights. It's going to help you see it more clearly. And now you can see the bulb is glowing. It's very dim. Let's bring it a little more close. Yeah, and now it's much brighter. More. Yeah, okay, so that's the distance. Now it's fully bright. Here I'm going to do this coil distance measurement test. So here, as you can see, that at 22.5 millimeters it is giving out full potential output. So it's around 2.2 centimeters. Now let's try some smaller loads like a CPU fan. Turning the switch on. It's running. Let's increase the distance. Yeah, and this time the distance is much more than before and it is still running. Let's see the maximum distance capability. Oh, that is pretty huge. Let's go more. See, it's fallen down, but the fan is still running. So that's the transmitter circuit, and the distance between the coils is also huge. And here, as you can see, that the receiver LED is glowing, indicating the incoming power, and the fan is also running. Now let's measure the distance between the coils. So here we have 84 millimeters, which means 8 centimeter. That is pretty good. Now, as you can see, that right now the bulb is not glowing, and here I have this ferrite core. So I am going to place it inside the coil and let's see if it glows this time. You see that it is glowing, and if I remove it, then it is still glowing but much lesser in brightness. So the ferrite core increases the induced flux. Now let's use this ferrite core and move it in between like this. It's getting dim. Yeah, it's completely out. Yeah, not glowing at all. But this one increases the flux linkage somehow. If I go all the way through, it is still working. In the middle, it is the brightest. Let's bring the coils closer. Okay. Like without the ferrite core, you can see that it is glowing this much. Let's bring it close, and the brightness has reduced a little bit. See, this was the initial and it has reduced. Now let's move along to the middle. It is much more bright this time. Now let's proceed further. Yeah, it has reduced. Middle, brightest. Okay, so that's the effect of the ferrite core, the cylindrical one. Although something happens with this one, as soon as I put it in the middle, it turns off completely. Okay. Nothing. If I bring them closer, so it's logged to the maximum brightness. Hi guys, these what you see are a few old lithium ion cells. Now these cells actually died 10 years back from now, and I discarded them for that very reason. But after so many years, when I checked them back, they revived, and I don't know how that is possible, but it did happen. Although the cell voltages are different, hence this video. Now this is a transformer with only 220 volts primary winding and no secondary winding. And this is my 1 mm super thick copper wire. for secondary winding. Now here as you can see that I'm giving it 3 turns on the secondary to figure out the voltage per turn. And here as you can see that we have 0.7 volts AC for 3 turns. So here I've given around 28 turns to the secondary, and now it's time to measure the voltage that it is producing, which as you can see is exactly 6.6 volts as I wanted. This video is sponsored by Next PCB, which offers you 10 pieces of 1 to 4 layers of PCBs without any cost. Also, now you can upload Gerber files without filling the data one by one. New users are also getting $100 of joining bonus after they register to the Next PCB website. Links in the description. So guys, here I've used 7 pieces of 1N4007 diodes, and all of them have been connected in series to prevent the supply voltage from rising beyond 4.2 volts. (330 ohms resistor). A link for the files to download this type of box and 3D print yourself has been provided in the description, so don't forget to check it out. It fits the batteries perfectly, and at present also it is balancing the batteries since all of them have been connected in parallel. So let's check the overall voltage that we have gained, and it's simple and easy. Simply slide the cover like this, and this is for easy slide, like very easy, and this is the stiff side, little stiff, so it's not going to come out easily. So both the provisions are available. Testing it, seems like no connection is there in between here and here. Let's try this side, and here we have it, 3.4 volts. So the batteries are obviously discharged. This side is positive, and here we have plus 3.4 volts. It's also connected to this one and this one. So 4 batteries are under balancing, and these batteries are under balancing with their neighboring cells. So guys, the circuit is fully complete now. It's time to test its output voltage, and we also have an LED indicator that is going to indicate that our circuit has turned on. Now guys, 220 volts is going to come from this side, and this is the transformer, which is in turn going to produce 6.6 volts, which we have already seen. This is the input side of this circuit. So the connections have been made. Let's turn on the switch, and here the LED bulb has started glowing, indicating that the circuit is on. And here, as you can see, that we are producing a safe voltage of around 3.9 volts DC for our lithium ion battery pack. Now here I've already marked the positive and negative side. You see that's negative and this one is positive. And here I've also soldered this piece with my spot welding machine, and this is going to be the positive and this is going to be the negative on one single side. It's going to be easier. And the best part is that you see these spaces here. That is going to be very useful for placing these like this. So we have like positive over there and a negative over here. So it's 3.6 volts almost. Now negative will be connected like this and positive, and here as you can see that it has started charging. So let's test our battery with this 12 volts bulb, and you see that it's working. Cool. Hi, this is an old photocopy machine motor and it's damaged. Moving on to its ratings, voltage is 24 volts, power is 64.7 watts and RPM is 180 rotations per minute. Moving on to the damages, as you can see the shaft is bent, plus if you have a closer look over here, you can see this part of the PCB is damaged, so the circuit is incomplete from here to this point. Now, there can also be some other faults, but to know that for sure, we will have to open it up and have a closer look at it.
Next level.
So that's the rotor. As you can see, it contains 4 ferrite magnets, and this is your armature winding. Beautiful as always. These, as you can see, are the FETs, which stands for field effect transistors. So let's open it further. Here, as you can see how thick the copper wires are. Here you can see the breakage. You can see all of it is damaged, so I will have to repair it. So it's all dry now. So guys, I straightened it up as much as I could. Let's hope it works fine. Here, as you can see, the gearbox is fully complete, and that's the first time I did the alignment type of job. You see, it's a little wobbly, but I did the best I could. Much better than before. Like, nobody gets perfect in their first time. So much better than before. Now, to test if it runs or not, first you will have to know about its connections. Take the first red wire and connect it together with the fourth one, which is also red. Next, you will need a 500 ohms resistor. Next, connect one terminal of the 500 ohm resistor together with the joint. Next is we have to take the last wire, which is orange here, and connect it to the other end of the resistor, something like this. Next, out of these black wires, you have to take the first one and connect it together with the orange one. Next, short circuit all the black wires except for the first one. See, that's the first one. It's disconnected. Rest are shorted. After that, simply take a 24 volts power supply and take the positive wire, which is white one here, and connect it to the first red wire. Next, take the black wire, which is negative, and connect it to the black wire of this motor. Now, all you are left with is one single wire, which is the field sensing wire. Turning on the supply. Here, as you can see, it's flashing 24.3 volts. So, cutting off the wires that are not needed, i.e. blue and red. Now, take this disconnected black wire and touch it to anything metallic. You can see the shaft is still wobbly. Now, because the shaft was wobbly, so I'm going to use another gearbox, an identical piece that I found in the scrap market. This is the old one. Now let's test it again. You can also start it by touching this wire to the bundle. The torque is very strong.